Alright, we are recording now. So, going over your warm-up, all you were asked to do was determine if the relation is a function. Number 1 is yes, number 2 is yes, and number 3 is yes. They were all functions. So, number 1 was given to us in table form. But when we write the domain, we need to write it as a set. Did you write the domain contains the elements, and you put them in braces, and you put them from least to greatest with the commas. So 4, comma 5, comma 6. Okay? And then the range contains the elements, -7, -2, 6. And you have them in order, and it's all pretty.
I did them as ordered pairs.
Okay. You cannot write them as ordered pairs because the domain and range would split your ordered pairs. Okay? So the domain takes all the x coordinates of an ordered pair, and the range takes all the y coordinates of an ordered pair. So you'd want to write them as a set. Okay, so number 2, we have a mapping. All the elements of the input are mapped to the output. The domain is mapped to the range. So the domain contains the elements 2, 3, 5. The range contains 1 and 2. Now, on number 3, this is our first one that is continuous. This line contains an infinite number of points from here to here. So we can't write it as discrete values like we did here. So the domain is everything from this x value over to this x value. So if we thought about this representing all of our x values, this number line down here at the bottom representing all of the x values, well, this segment only goes from -2 over to 4. So the domain of this function is from -2 inclusive to 4. And it includes the -2 because it's a closed-in circle, and it does not include the 4 because it was an open circle. Okay? Range. Range is our y values, and you always look from bottom to top. So if we're going from bottom to top on this, the lowest y value is down here at -3. The highest y value is at +1. So the range goes from -3 to +1. Okay. Form is critical. You can't mix up a bracket and a brace and a parenthesis. No, bracket and parenthesis. Or a brace. You can't mix them up. We use the braces when we're denoting a set of discrete elements. We use the brackets and parentheses when we're using interval notation to denote a continuous span. Okay? All right. Answers for the homework. We're going to start with a worksheet. Take a look at the domain and range at the top of the worksheet. See if you have any questions. All right. All of these should have been written as sets. Now, what we can't do is write a big D and then arrows that point to just where we want it to be. Okay? We really need to list the domain, list the range. And check your number 5. On number 5, did you just write the element 3 one time? We don't need to repeat. Okay, see if you have any questions on 1 through 6. Yes, I guess every day during 7th period it's going to thunder. Okay, it will either rain or it won't. Okay. All right, let's move on.
Do you know if it's supposed to rain tomorrow?
It's hot summer days. It could rain anytime.
I think it should rain all day.
No, it should not rain by Arizona.
It was not. My husband said yesterday there was only a 10% chance of rain, and we got 2 inches in our house.
I have time to say before it should rain Saturday.
All right, we're good. All right, let's move on. Okay, we did 7, 8, 9 yesterday in class, so we should all have those correct. So 10 is not a function, fails vertical line test right there. 1, 2, vertical line, pass through more than 1 point. Now, number 11 is a vertical function. It's a horizontal line. The domain, because it goes left forever and right forever, forever and forever, the domain is from -infinity to positive infinity. But because it's a horizontal line, the y value on the entire line is Negative 3. So that is the only y value. So it's not an interval. It's just one value, negative 3. So we have to write it as the set that contains the element negative 3.
And that's why there's the brace.
Yes, that's why it's the braces. Good. Okay. Now, this line is diagonal, and it goes up forever, and down forever, and left forever, and right forever. So the domain and range are both negative infinity to positive infinity. Domain and range are both, because it goes left forever and right forever, domain, up forever and down forever, range. Now, when we take a standardized test, they're probably not going to use interval notation. But the reason we do is because you guys are on the track to end up in calculus. So if you continue to be successful and you apply and you get accepted to calculus, that's where all of you will end up. So we go ahead and teach what's expected of you later on. But you ought to be able to understand that left forever and right forever, negative infinity to positive infinity, is all real numbers. And they might write that on an end of course test. Or they might write it as this. The domain goes, well, no, they're going to write all real numbers for this one. Yes, sir.
Shouldn't the range be switched? Negative infinity should be switched up.
Okay. In interval notation, it always goes least value to the greatest value. And negative infinity is the smallest we can ever get. So it always goes bottom to top, no matter what that end's going. So for range, we don't look left to right at all. We just go bottom to top. All right. Now this symbol, have y'all seen in English, have your teachers ever done the double P, or you should have started a new paragraph here? Okay. Well, this is similar to that. It's a double R. And this symbol in mathematics stands for all real numbers. Like the double I stands for the set of integers. The double R stands for the set of real numbers. So you may see this sometimes. I know when I was teaching the SAT class for the math portion, the double R did show up. And so we talked about how that means the set of real numbers. All right, the bottom here. Before you left yesterday, we talked for maybe 30 seconds about linear functions in particular. But that was okay, because last year you spent at least 6 weeks studying lines. Because I looked at your curriculum. So you should have mastered lines. You know y equals mx plus b. You know when you have a line, the slope is always constant. So if we looked at this, do we see as x changes by 1, y changes by negative 9, well, negative 9, then negative 7, then negative 5. Is that constant? No. So 13 is not linear. It was not constant. 14, as x changed by 4, y changed by 5. 4, 5. So my slope is 5/4, isn't it? Because slope is always the change in the y's over the change in the x's. We have a constant rate of change. So yes, this is linear. Now you also learned y equals mx plus b form. Is x ever raised to a higher power than 1 if it's linear? No. So on this one, right off the bat, you saw x squared and went, not a line. No. And this one's completely in the right form, number 16 is. So it works. Now, number 17, as x changes by 1, the y's went down by 2 every time. So we had a slope of, no, they went up by 2, excuse me. Positive 2 over 1, so we had a constant rate of change. So yes, was the answer to number 17. Do those make sense? Okay. Are we good? Okay. Those of you that have been writing notes to each other and coloring and things like that in class, as long as you made 100% on your quiz, I'm going to let you continue doing that. But if you made anything less than a 55 out of 55 on the quiz, you have to pay attention to me all during class. Deal?
Yes, ma'am.
All right. So let's take a look at the rest of our homework. This was our book work. Okay, 15 asks us to take this set of ordered pairs and show it 3 other ways. So this is the set of ordered pairs. Write it as a table. Boom. It didn't say horizontal or vertical. You could have done it either way. Write it as a mapping. Input, output. There it is. And then as a graph, plotted my points. Now if we looked at our graph, does it pass the vertical line test? Ooh. Yes. So is that a function? Yes, they didn't ask us that, but certainly. Any questions about number 15? Yes, sir.
For the mapping, shouldn't
Yes.
it be like -4, -1, 0? Because it's like these two greatest going down.
Ooh, that would have been better. Yes,
Okay.
it should have. You're right.
Thank you.
All right, 17. We talked about 17 yesterday. The one line that's not a function is the vertical line. So is this a function? No, this is just a relation, and the directions called it a relation, so we're good. We can give the domain and range of the relation. If we looked at this, every x value on that segment is a 3, isn't it? Yeah. Every single x value. So the domain only contains the number 3. But the range, when we go from bottom to top, starts with a y value of 1 and ends with a y value of 5. And it's every single little point in between. 1.76 is in there. 2.00005 is in here. Every little point in between. So we have to write this as an interval from 1 to 5. Now, if we were taking a standardized test for you guys, they still may write it as a compound inequality. But this means the same thing as that. So by the time we see those at the end of the year, we should be able to make that connection. And then this one, we just have a set of discrete points. So our domain and range for both of those would be the set 4, 5, 6, 7, 8. Okay, so is this a function? Yes, passes the vertical line test, doesn't it? The domain goes from the x values here at -2 to +2. And it contains the -2 and +2. It's hard for me to see that, but I guess it touched that line. So the domain goes from -2 to +2. The range, bottom to top, the lowest y value is 0. The greatest y value is 2, from 0 to 2. This one is not a function. Why is it not a function?
It has two
There's one domain that goes to 2 ranges.
One element of the domain is paired with 2 elements in the range. Each element of the domain can only be paired with 1 element of the range. Okay, number 21, here's our equation. Number 22, it says let the independent be the length of the side of the square, and the dependent, the y, represent the area of the square. Well, to find the area of the square, don't we just do side squared? So 2 squared is 4. 4 squared is 16. 6 squared is 36. Make sense? Okay. Any other questions about 21 or 22? Okay. 24. Is this a function? Yes. I graphed it. It passed the vertical line test. Crazy looking, but eh. Okay. All right. Just check these. Start with 27. 27 is no. 28A is false. 28B is true. 29, you could have either written it as a compound inequality or as the intervals. So check those for 29. It is a function because each x is paired with exactly one y. Do you see how I've never used the phrase because the x's don't repeat? Okay, good. You don't ever use that phrase either. Yes, sir.
I'm confused because would you use like there where it's like 0, 5, or would you use like 0, infinity?
Okay, let's take a look at this question. Do I have my book still open? This was on what page? It was not 207.
197?
Okay.
Or like 198?
198.
Nope. Yeah, 199. It was the first problem on 199.
199? Okay.
Since it's an arrow, I put infinity.
It does have an arrow, and I understand why you would want to put infinity because of the arrow. That arrow was deceiving. But can we continuously put water in the pool forever? No. Eventually, it fills up.
So the
So our domain is going to be restricted on because of how much water the pool can hold. We can't fill it up infinitely for an infinite amount of time because the pool won't hold that much water.
so that graph is like wrong, or is that graph still right?
It should be like a.
It's wrong.
I think the graph is incomplete. I think the graph should not have an error at the end.
Like, so,
If you said it went to infinity, you are correct given the graph.
yes.
But do you understand why that makes no sense?
Yes.
Okay. All right. So if you said it went to infinity, I can understand because the graph has the arrow at the end. And actually, that's something we're going to start talking about. What is a reasonable domain? Does it make sense to go on forever? No. Most of the time in real life situations, forever is too much. So, so we're going to talk about reasonable domains. All right. So this is a little deceiving because it did have the error and it didn't give us enough information in there to determine at what point the pool would be full. They would need to give us that. Okay? On this one, the relation is a function because each pair x is paired with exactly one y. And then it's dgd. We good? Alright. And then we have this nice set for 35a. And so we pick off the independent or the x values and that gives us our domain. We pick off the y and that gives us our range. And yes, each value in the domain is paired with exactly one in the range. So yes, it is a function. Okay. Let's just go through this quick. 15 is yes, then no. 16 is yes, then yes. 17 is yes, then no. On 18, we had a constant change in our x's, but that was corresponding to different changes in our y's. So we wouldn't have a constant slope, and we wouldn't consider it linear. Yes, sir?
You say that it does not increase at a constant rate?
Right, good. So the x's were, but since the y's were not, there's not a constant rate of change. Okay? Now, this one, our x's were increasing by 1 when our y's were increasing by 1. So this one did have a constant rate of change. So the constant rate of change was 1. It was 1 over 1. This one said the x's were decreasing by 3 while the y's decreased by 2. So slope is our change in our y's over change in our x's. So the slope would be 2/3. Yes. This is a line. It is a linear function. Okay. 21 was yes. There's the horizontal. 22 is yes. There's the diagonal. 23 is no. And then 24. When we rewrite this and solve for y, we get y equals 1, which is this horizontal line. So no matter what we plug in for x, y is always 1. Well, there's no place to plug in the x, is there? So no matter what, y equals 1. So when we're making the table on these, no matter what value we pick for x, the y is 1. We good? Yes, sir.
I messed up on 23.
23.
I mean, I got the answer right, but I didn't really. I think it was more of a 50-50 guess.
Okay, what page was this? This was that second section. So this is page 244 or 245.
On that page.
First one on 245. Which question was it? Okay, so let's take a look at 23. What keeps 23 from being linear? When we have y equals mx plus b, is x ever in the denominator? No. So this is what makes it no. That x in the denominator takes it from being a linear function and turns it into, you will find out later, that's called a rational function. Okay?
Is that the one that question?
Yes.
121.
On this section?
It was in calories.
Okay.
24.
24? Okay. This one, if we created the graph, the number of fat calories depends on how many fat grams there are. So I put fat grams as my independent variable and graphed it on the horizontal. So the fat calories depends on the grams. I graphed it on the vertical. And we would consider this a function. While we have the graph there, it passes the vertical line test. Okay? All right. Today we're going to kind of stick with the linear mode, and then we're going to evaluate some functions the second half of class. So this is on your calendar. It's the ones on your calendar that said for Thursday we were going to do in class. I picked out a couple of those, and these are out of your books. So the first thing it asks us to do is determine a relationship between the x and y values in these equations. So if we're doing that, we're hoping they're linear because we are good with y equals mx plus b. We know lines. We know y equals mx plus b. We know y minus y1 equals m times x minus x1. Point slope. Okay. So if we look at number 13, and we try to determine if this has a constant rate of change, we're looking at the change in our y's over the change in our x's. What is the change in our y's? They're going down by 2. And what is the change in our x's? Up by 1. So the slope is -2, right? So if I plugged it into y equals mx plus b, all we need now is b. Well, do you see how this started with 1? How hard would it be to go back to figure out 0? It would be 0. So we know b is 0. So the equation that models this function is y equals -2x. Does that make sense? All right, the next one. Instead of giving us a table, this time they gave us the set of ordered pairs. Okay. But we're still going to look and see, is this a linear function? Because if it is, it would have a constant rate of change. So let's look at our change in the y's over the change in the x's. All right, so the y's are going down by 1, as the x's do what? Up by 1. So we have a constant rate of change of -1. Now, I'm going to show you how to use the y minus y1 equals m times x minus x1. And you guys, point slope. Yep. So you've already used this. This is not new. And all you have to do is pick a point in here. So let's say we pick this one. We plug in 2 for our x and -2 for our y. So what happens to minus a negative? It does. And we distribute the negative here. And then we subtract the 2. And we get y equals -x. Now, I still want you to rewrite it into into y equals mx plus b form, into slope-intercept form, because that's what you're going to see on any state-mandated test we have to take. Now, later on, starting next year, we're going to let you leave them in point-slope form. And once you get up to calculus, any line you could just leave, just like this. Done. Put it in slope, point slope when you're done. Okay?
Because you know how to solve it.
Yeah. Yep. Okay. Number 15. This is where we're identifying the independent and the dependent variables. And that's important for us because that helps us figure out which one's our domain and which one's our range. Now, the way I always ask myself this question as I go, okay, what depends on what? So I read it. Gardeners buy fertilizer according to the size of the lawn. The amount of fertilizer depends on the size of the lawn. So the fertilizer is the dependent variable. The size of the lawn is the independent. So this is our dependent. Size of lawn is our independent. Make sense? Okay, so on this one we have the cost of the gift wrap, and the cost to gift wrap an order is $3 plus $1 per item. So we have two things here. We have cost and we have number of items. Which one's independent?
The cost. The number of items.
The number of items. That's our independent, and the cost depends on the number of items. Does that make sense? Okay. So cost is our dependent. There we go. All right. Now this one, I'm going to scratch that out for a second because that's too easy and we can do that ourselves. All right, Air Force One can travel 630 miles per hour. Let H be the number of hours traveled, and we're going to find a function that gives the distance in miles that Air Force One can travel in 8 hours. So we're supposed to identify the independent and the dependent variables. What's independent?
Hours.
Hours. The hours of travel. And what is dependent? The distance. So the distance traveled depends on the amount of time we have traveled. Does that make sense? Okay, so it says to write this using function notation. So distance with respect to hours is 630 h. D of h equals 630 h. So we travel 630 miles per hour. What are reasonable values for the domain and range of this situation? Okay, if we said reasonable values, what is the least amount of time we can travel?
A second.
0. It's what I'm traveling today. 0. Now, can we really travel forever? No. But this problem would need to give us more information so we would know when to stop. I mean, we could argue that we could get in a plane and then we could have another plane come by and fill it up and our plane could keep traveling and we wouldn't have to land. But eventually something mechanical would go wrong and we'd have to land. Okay? Alright.
And we can just jump on another thing.
Oh, okay. Yeah. Okay, so y'all wanna travel forever, I'm hearing it. So you're going to travel for infinity. This problem isn't specific, so it's hard for me to determine a stopping point. We know it has to be some amount of time greater than or equal to 0. We don't know where the end is.
Can you just write it in the column?
I'm going to give you situations where it's clear where the end is. Okay? I'm going to give you an end. Our range, well, if we don't get on the plane at all, how far are we going to travel on the plane? 0 miles. And since we can travel forever, we can travel an infinite distance according to your situation. Okay, how far can it travel in 12 hours? What would we do with the 12?
Multiply by 630.
Now, what if this had said the plane holds enough gas to fly for 18 hours? What would the end be? 18. And so, what would we do to find the end of the distance? 630 times 18, whatever that is. Okay? So, now this is not the answer to the actual problem in the book, but the made-up example we were just talking about. Okay. Number 32. I just made up the 18. I just made it up. I said, let's say the plane can hold enough gas to travel for 18 hours. Then our domain would look like this.
Wait,
And our range would
do you
look
still
like
have
that.
parentheses or just because it's
I don't want my plane to completely run out of gas. I don't know about you, but I would want mine to stop right before we ran out of gas. At least. I'd even be happy if it stopped way before then. Okay. Alright, here's another pool problem, guys. This table shows the volume of pool pumped after T hours. So we have how long the water's been pumping and the volume of the water. Now, does this equation make sense given this situation?
Yeah.
Do you see if I plugged in 1, I'd get out this. If I plugged in 2, I'd get out this. Okay? This is our rate of change, isn't it? Our rate of change is always multiplied times our independent variable. And then we would have to see what our y-intercept was, which in this case is 0. So we don't need that. And there's our equation. Okay, our independent would be the time, and the volume of the pool water is dependent on how long we've been filling it. The pool holds 10,000 gallons. How long will it take to fill? So that's an important information that would give us the ending point of our domain and range, wouldn't it? So if I would give you something like this, I would say, okay, this pool will only hold 10,000 gallons. So then you can figure out how long you can fill it. And then we would also know the range would go from 0 to 10,000. And then the domain would go from 0 to whatever is 10,000 divided by 8. It's 8?
Yes.
Okay. Beautiful. Okay, so I like this one because it gave me an ending point. All right. The next thing we're going to look at is a little PowerPoint about functions. And they really liked this last period. So, if we're given this is a function, f of x equals 3x minus 2. What kind of function is this specifically? It's y equals mx plus b. So what's the special name for that kind of linear function? All right. What we're going to do first is evaluate a linear function. And we looked at this a little bit yesterday. What does this say? This says plug 3 into the function f. So when we think about it, you can think about it as a function machine. We have our input. It's going into our function, which was 3x minus 2. So when we plug that 3 in, what do we get out? 9 minus 2 is 7. So this statement, this statement right here says, when I plug 3 into function f, I get out 7. When I evaluate the function f with a value of 3, the result is 7. That's what that statement says. Plug 3 into function f, the result is 7. Okay, so this one says to plug negative 2 into function f. See if you can find out what the result is. What does that equal? You got it. All right, what'd you get? Negative 8 is correct. When we plug negative 2 in, we get out negative 8. So this is our answer. Now, be real careful. This does not mean f times negative 2. If we wanted to say negative 2 times f, wouldn't we put that negative 2 in front? Yeah. This is function notation. And what this means is, I plugged negative 2 into function f, and the result was negative 8. And that is how I would write my answer. That's what your answer would look like. Okay, we can evaluate any type of function. It doesn't have to be linear. This one's quadratic, but we could still do it. So all we would do to find h of negative 3 is every place we see the z, what do we plug in? Negative 3. So it would look like this. Negative 3 squared, negative 4 times negative 3, plus 9. So it gives us 9 plus 12 plus 9 is 30. So what this says is, when I plug negative 3 into function h, the result is 30. So we don't divide by -3 right now. That's not what this is saying. This is not -3 times h. Not at all. That -3 would be out in front, and we wouldn't be talking about the function h. Okay. You try. You've already got it. Cool. You are correct. The answer is C. Okay? Do you want to see why? You want to see why? Or are we good? All right, where'd it go? Okay. Oh, I erased them all. So on this one, if we plug 4 in, we get 4 squared minus 2. G of 4 is 16 minus 2, which is 14. So G of 4 equals 14. Okay? Let's look at the next one. Oh. It's not a number, is it? So what do we do? We're going to do the same thing. We're going to take this and plug it in and have to use the distributive property. Perfect. Okay? So when we look at this one, we're going to do G of x plus 2. So the x plus 2 gets plugged in. And we have to distribute the 3. And so we get 3x plus 6 minus 1. So G of x plus 2 is equivalent to 3x plus 5. Okay? Does that make sense? All right. Okay, I'm going to skip to the last one real quick. Okay, now, when we look at this one, do you see they didn't give us the x? They told us f of x equals 15. So can we substitute 15 in for f of x? Yeah, because that's what f of x equals. So 15 equals 2x plus 1. And now can we find x? Yeah. 14 equals 2x, 7 equals x. Okay.
Well, it's plugged in for FX.
That's right. They didn't give us x, they gave us f of x. Okay?
Oh, this